So we're just waiting for the rest of the folks to join. So we'll begin the formal talk in about 5 minutes or so, just to make sure everybody gets a chance to log in. There's a lot of people in the class, so we'll have to just wait just a moment until everybody gets themselves in. It's a lot of people. It looks like a beaker, but it's really a cup. So you should never drink out of your chemistry glassware. Okay, it's about 5 minutes into the course, so let's go ahead and I'll just keep admitting people as they join. But let me just go ahead and introduce myself and let you know a little bit about me and the way this course is going to be structured. So my name is Phil Brown, and this is Chem 220, CH220, Fundamentals of Organic. Now, Chem 220 is not a replacement for Chem 221. So if you are hoping to, let me get that rid. Sorry about that. If you are hoping to take this course as a replacement for Chem 221, that's not going to work as a substitute for the prerequisite for Chem 221. That's a 2-semester sequence. 221, 223 designed for a different purpose. So hopefully the course you are in right now is what you need. If not, this is drop add week. so you can make adjustments to your schedule and hopefully get into the appropriate course if this is not what you need. Now, again, my name is Phil Brown, and so I went to graduate school here at NC State. I got my PhD here. I went to undergraduate school at Boston College. So my heart lies with BC all the time, unless NC State's playing BC, then my allegiances are split. So we're gonna go ahead and look at several things for today. So I'm gonna share my screen with you right now. I'll keep admitting people as they log in here. I am going to pull up a screen now that's going to have a little bit of an overview of what we're going to do today. So let me go ahead and share this screen, and hopefully everybody can see this. Well, that's not the page I want. Let me go one more. It's been a while since I've taught. I'll give you a little bit more of a hint. I'm actually a retired faculty right now. And so to technology, I'm pretty good at, but it's going to take me some time to get used to everything. So I'm going to use my iPad to do a lot of work with you. So hopefully everybody can see this. Let me close that off. So everybody, this is Chem 220, as they say. First day, we're going to do a course overview. We're going to look at the policies and the procedures. We're going to talk about exams. A project is going to be required. I'll talk more about this towards the end of today's lecture. And then we're going to talk about expected prerequisites. So we're going to actually even briefly just get in. Now, a lot of this is going to be redundant to most of you. So if you want to tune me out as I talk about these, that's fine. However, I looked at the people in the course, and it does look like a good number of you have been, it's been at least a year or two since you've taken Chem 101, General Chemistry, which is the prerequisite for this. So I'm going to just do a very cursory overview of general chemistry, the really essential concepts that we're going to need in order to be successful in the course. But that said, this is not an overly technical chemistry course. It's going to be very rare from what the chemistries you've had in the past. This is going to be more of an overview, of sort of a bird's eye view, looking at mostly organic compounds that are going to be important to you. And by you, I mean all the different majors in this class. There are so many different people in here that it's going to be up to you to get what you want. All right, so I'm going to stop the share right now. And I'm going to pull up what we call Moodle. I hope most of you know what Moodle is. It's a course management system that kind of assembles a lot of the important documents that we're going to need for this course. So I'm going to share my screen with you again, but this time I'm going to pull up Moodle. Go here. Okay. So this is the Wolfware, the Moodle page, or how you get to Moodle. Just wolfware.ncsu.edu. There might be a few people who are new to NC State and don't really have an idea about it, but this is how you get to it. So wolfware.ncsu brings up this page. Now over here is Moodle, and then we have Panopto, and we have Zoom, and I'll talk about that later. Zoom is what you're in right now. All right, so let's go to Moodle and bring up the course page. All right, so here's Moodle. And
hey, Dr. Brown, we can't
now
see
this
your
is only partially populated right now. there are many, many other parts of Moodle that we're going to get into later on. But I was called into service very late. A little bit of background on me. I actually retired last year, and the university had a great number of retirements and resignations last year. So they kind of brought me in for an encore performance to do this class. And since there was a number of graduating seniors that I see, they kind of guilted me into coming out of retirement. So that's what I did. All right. So you see on this Moodle page, we have the syllabus, the schedule. Now these will change. You don't have to print these out right now. And I recommend you don't print them out.
Excuse me, Dr. Brown.
Change a little bit, and they will have little variations in them. So, you'll always have access. Anytime you can get to Moodle, you'll have access. These are the three textbooks. You don't have to buy anything for this class, by the way. This is a sort of an overview of general organic and biological chemistry, sort of a survey textbook. And these two are volume 1 and 2 of a very more intricate organic book. Now, these are all only for reference. We're not going to use this as our primary source of information. The lectures are going to be your source of information. So keep that in mind. And then we keep going down here. All right, so let me get out of here, and I am going to stop my share.
Excuse me.
Oh, did you not see that?
I haven't seen any.
You haven't seen any? Oh,
yes.
All right, let me share my screen again, and I will bring that up. Can you see that now? No? Still can't see that? No.
Yeah, we can see it now.
Can you see it now? Oh, thank you. Good, good. Okay, so again, here's this Moodle page that I just described a moment ago. And you see syllabus and schedule are two things that you're going to need that are going to maybe change a little bit as we go along. So keep that in mind. Here's just one textbook, an online textbook that is just generic in nature. If it's been a while since you've had general chemistry, this is sort of a nice resource. These next two, organic with biological emphasis at volume 1 and 2, this is a much more intricate book, and it's even designed mainly for a full semester organic class. So don't worry about these two. All three of these books are for reference. The lectures are your main source of information, as we'll see as we go along. So keep that in mind. Here's like the part 1, organic chemistry of fuels. You're free to browse around here. If you want to look at some of these videos, there's some cool stuff here. I'll alert you to a few of them as we go through the class, but you don't have to worry too much about the videos and other ancillary materials for the moment. All right, so let me stop the share on the Moodle. Well, you know what? Yeah, let me stop the share on the Moodle for a second. Oh, we've got a few more waiting to join us. Let me go ahead and let them in. Okay, hopefully they're able to get in. All right, I think the remaining people are still here. If you just joined the class, don't worry about it. This is all being recorded. So if you happen to ever miss a class, if you get sick or God forbid you get the COVID, as you can probably tell, I don't feel that great right now. I don't think I got the COVID. I think it's something else. But who knows at this point? Seems like all my friends have the COVID now. But, I guess I'll just see. I'm going to take a test later this afternoon. So we're going to have to be flexible in this course because we don't know what the COVID situation is going to be. So as of now, I plan on just being in person starting next week. But that could change. And I will let you know that. I'll send out an email and I'll let everybody know that if we must continue, we'll just continue online. I know this is less than desirable, definitely less than desirable for me. I can't stand online classes, but some people love them, and it's nice that you can review them as many times as you want. Go forward, pause a lecture, stop it. That part is kind of nice. So fortunately for you, you get the best of both worlds, because the lectures are all going to be recorded, whether they're in person or via Zoom. So, you know, if you have a conflict and you just can't make it, don't worry about it. Just pull it up later that evening or over the weekend. But do look at the lectures when you can. All right. So let me share my screen with you again, and I'm going to talk a little bit. Let me go back to our page here. So course overview. Let's look at this course overview. What is it that I'm trying to achieve in this course? I don't want you to have any intricate knowledge of organic chemistry. There's not a single chemistry major in this course. So this is much more about, some more people joining. This is a course that's much more about the organic chemicals in your world. Now, your world is going to be different than somebody else's. We have people who are environmental science majors. We have people in this course who are ag and life science. We have people who are agronomy majors. We have people who are textile majors. There's a huge variety of people. But as you'll see in a moment, I hope to give everybody something. And your course project will be something based upon something that you want to do, some kind of knowledge that you want. It doesn't have to stay in your field, but I hope it does. All right. So let me stop this share for a moment and bring up a different page. Bring up. Let me go. Sorry, it takes a second to get all this stuff lined out here. I'm going to share the screen again, but this time I'm going to bring up a schedule. Hopefully everybody can see the schedule. It's kind of small print. Let me try something, see if I can make this bigger. Doesn't seem to want to go bigger. Well, that's okay. Just take my word for it that this is sort of a general overview. Now, the thing that you have to note here is tentative course schedule. Again, a very fluid situation. So here we are today, Tuesday, the 11th, and then policies, course overview, and a quick general chemistry review at the end of my little intro spiel here. Now, what you see over here, you see these chapter readings? General, organic, and biological, 1 through 4, okay? So chapters 1 through 4 in that general organic. This is where you will find stuff on the general chemistry stuff. You will also find, you see this thing that says V1.7? That is the second book on the Moodle page, that more intricate organic book. And that takes you to some more knowledge. And I, again, am I going to go into great detail about a lot of this stuff? Probably not. And you'll see as we go along. This again is a class more on overviews. So the thing that I do want to scroll down before I get too far. Okay, you see here on 2/17/22, exam number 1. So you never have to come to class. I hope you do. But if you choose not to and just do the videos, that's fine too. It's up to you how you want to approach the course. but I hope you do come to class because, you know, sometimes I get more animated. And the nice thing about in class, I can do some demos that I can't really do here in my house for fear of burning my house down. But these are the only times you have to be here, where you have to be in class. You don't get to choose to take your exam online. Okay. Now, a caveat though, let me tell you. So if you are a disability service student, DSO, you take all of your tests over with disability services, but you still have to come onto campus that day. So how many times must you be here? You have to be here on the 17th. And again, this is tentative. Hopefully that won't change, but you know, we have to be resourceful here. The next one, where is it? Spring break. Here we go. Down here, exam number 2. On, let's see, 4 or 5. On April the 5th, that's another Tuesday, is exam number 2. We always have a review for the exam prior to the exam. So the day before the exam, I kind of go over stuff that I want you to know for the test. And again, you shouldn't really stress too much about the test. I tell you, if you just do the homework, you do the Kahoots, I'll talk about Kahoot in a minute, and then you also just listen to the lectures. I don't think these exams are going to be much of a challenge for you, okay? You can kind of see here too, by the way, the kind of overview we have here. So we're going to talk about some environmental chemistry, global warming. We're going to talk about pharmaceutical chemistry, both medicinal as well as drugs of abuse. We'll talk about toxins and venoms and biological peptides. We'll talk about environmental science. We'll talk about food chemistry, nutrition science. I saw a lot of food science majors in here. That's good. Sort of a topic near and dear to my heart. COVID kind of put a little weight on me, so I'm very active at the moment, trying to drop a little weight, and I'm getting back into my running. We'll talk about the different carbs, proteins, and fats that are part of foods, as well as vitamins and minerals. We'll talk about that. Now, on the 19th, that is your final project due date. So now you could submit your final project earlier than that. And I recommend you do if you have a busy semester. So if you can work on your final project and get it in early, well, first off, that makes life easier for me. Then I don't have to read as many all at once. But this is the deadline right here. So this is another one you have to keep in mind, the April the 19th, okay? Dead week starts that week, and then on the 21st, we'll review for the final exam, and that's kind of the last day is the 21st here, because then the following week are your reading days, and you'll have the ability to kind of shore up your knowledge there. Now, this one you don't want to miss, the final exam, okay? That one you have to take. Make sure you don't miss that one. Because if you do, then we have to give you an incomplete, and then you have to come back another semester, which probably means I'm not going to be the one teaching the class, and you'll have to just take the whole class over again. And you don't want to do that. That would be a real pain. Okay, so let me stop the share here, and let me bring up the syllabus. That was the next thing we had to do on our lineup here. Share screen and the syllabus. Again, this is available to you at the Moodle page. So don't print it out. Please don't print anything out. First off, you're wasting paper, and we're going to have a lot of talk about environmental science here. So please don't do that. All right, so this just gives you the title and you know, our meeting date. This is where we normally are going to meet, and starting next Tuesday, hopefully, this is where we're going to be. But if COVID is still rampant, we have 225 people in this class. The whole lecture room only holds 250. So you can see how tight a space that is. That many people all sharing the same air. You know, I really don't want anybody to get sick. Fortunately, the Omicron seems not quite as bad. So I guess there is some blessing there. I hope you all have your vaccines. The university doesn't require it, but boy, I really hope you do. All right. So how to get a hold of me? Here's my phone number. This is no longer valid. So this is a dead number. Because I retired last year, I don't think you can get a hold of me here. I'm going to try this again, but it didn't work last week. But I'll try this one more time. So the phone number might not work. If not, this is how you get a hold of me. Phil_Brown@ncsu.edu or PA_Brown@ncsu.edu. That is our primary source of communication, is through email. Now, I do have office hours. Normally, they're just Tuesdays and Thursdays from 10 to 11:30. And then I can also offer virtual office hours by appointment. And basically, it's a Zoom meeting. So if you want to get a hold of me, or if you have something more private, I prefer that you do it just individually. So if it's just a matter of chemistry questions, that's not a problem. You can do that anywhere. Even by email is fine. But if you got something that's not related to chemistry, I prefer that we chat, offline there. Again, the online textbooks, they're all free. I just told you that in the Moodle page. The other thing I would like you to get is this chemistry drawing program if you got a PC. If you don't got a PC, there are alternatives, and hopefully most of you got the Mac alternative, or will get the Mac alternative for but we're going to do a lot of drawing of structures electronically. The other thing that you're going to need that program for is your project, because you will incorporate structures into your paper. And that's going to be very helpful for you to know that. Now, during the lectures, I oftentimes ask questions during the lectures. This is both for you and for me, so that I know if you're getting what I'm saying or not getting, then I can go back and review it. So the program is called Kahoot, and here's the link for it. Now, I sent out a file that had your student number and a Kahoot number, which you would follow by a PB, by the way. So whatever that number is, right after it, you say lowercase pb. And then I will populate the Kahoot course. And again, this is all next week, not this week. Since drop add week, we're not going to have any labs this week, no labs. That's a whole separate course. I'll talk about that in a minute. And we have Kahoots next week, which is basically just a little quiz tool that you'll do online. And again, you could do this if you don't come to class, but you have to be online. Otherwise, you won't see the Kahoot. But you have to be online during the class time in order to do a Kahoot. All right, a lot of people are interested in grading, which you should be. Grades are important. My guess is this is not one that you should stress about, this particular course. This is a namaste kind of a course. So I'm not here to teach organic chemistry to a lot of pre-med majors. This is basically a course designed to enrich your appreciation for chemistry. So we're going to have two in-class tests. And I say 1.5 hours, but typically they don't take 1.5 hours. They're usually designed to be about an hour long. Now, if you finish early, obviously you can leave, but if you want to take the whole 1.5 hours, you can. So that's that. In addition, we have a 2.5 hour final exam. We already talked about when that is. The other thing that part of your grade is a project paper required on a topic of your choosing. And I'm going to put out some suggestions next week. You don't have to this is just for you. You don't have to go by what I say. You can choose whatever topic you want. But what I want you to do is let me look at your topic before you start researching it. Just get my approval before you actually start diving into it. Okay. Okay, so then we have the Kahoot grade. Those little things. That's 5%. And then the homeworks are 10%. Now, let's talk about Kahoot and homework for a second. So many times you won't be able to get online during class time. So you'll miss a Kahoot. You know, can I make it up? No, you cannot. So, but here's how I do that. As long as you get 75% or more of the possible Kahoot or homework points, I will consider that a perfect grade. You get all the credit for that Kahoot. Now, so you get the full 5 percentage points if you can make 75% of the 100% points. Now, what if you don't make it? That's okay. It's prorated. So if you only make 70% of the 75, it's 70 divided by 75 times 100. That's how much you would get. So you get like 4.2 points. Same thing for the homeworks. They're prorated. You got to get 75% or more. Now, what if you get more? Do you get more? No. So that's the maximum you can get. But if you get 75% or more, you get the full perfect homework grade. All right. Now, here's a big note. Note, if an exam is missed, one of those first 2 tests, not the final, this doesn't apply to the final. If an exam is missed for any reason, that is the low grade in the course, and that is reported as a 0. And you don't have to tell me why you missed a test. Good excuse, bad excuse, it doesn't matter. We just don't make them up. Now, if you have a legitimate excuse where you have to miss that day, let me know like a week ahead of time. You can take a test early, okay? Early, if it's a good reason, not just because I want to take it early. You got to tell me, and it's got to be documented. You know, I need a letter from your parole officer that says you got to be in court that day, or your track coach, or whatever it might be. All right, so do that. Now, if you miss a test, that's okay. Don't worry about it, because what I'm going to do is whatever score that you get on the final exam, that is going to go into the place where the exam was missed. Now, that puts a little bit of stress on that final, right? So if you miss a test, you could be possibly looking at 40% of your overall grade coming from one exam. Now, so hopefully you'll be able to take all tests. Now, here's the other thing with these exams. So if you do get to take both exams, if both tests are taken, and the grade on the final, if your final exam grade is higher than the lowest score of those 2 tests, I'm going to throw that away. I'll throw away the low test, and I'll place the final exam grade in the spot of the low test score. So it really, you know, there's really no reason to miss a test. So let's say you just don't feel well, just go ahead and try it. Try the test anyway, because I'm going to throw away that low test score, and the final exam will take its place. All right. All right. So here's the grading scale. It's typical. So here's the A's, the A. Now, how can you get over, how can I get an A+? I want to get an A+. Well, that means you got to get a score higher than 100. Now, how in the world do you get a score higher than 100? Well, on the exams, I curve them. So if the average is lower than a 70%, I give points back to the whole class, okay? So if the exam score average was a 65, then I cough up 5 points to get up to the 70. So you see how you can get over 100%, okay? And again, A minuses are typical. So it's a very typical grading scale, and you'll see it here. Okay. Now let's talk about that lab. There is a lab associated with this course, Chem 222, but I do not have input into the lab. That's a whole separate grade. So you get 3 credits for this class, and you get 1 credit for the lab. Now, if you have any questions about 222, here is Dr. Gallardo Williams. Here's her email. She's the director of the OChem labs, and she can help you out with any problems you have there. We do have a chemistry tutorial center, and here are the hours. Somebody told me that the original link wasn't working. I cut and pasted the new link here, and I think this does work now. So there is no tutorial center hours. If you look at that schedule, there's no hours this week. They don't start till next week. And so hopefully you can get online and see if any of those fit into your schedule. This course doesn't have an SI leader. Some of you are used to supplemental instruction, but we do not have supplemental instruction for 220, unfortunately. But the tutorial center is there for help if you need it. And again, just email me. I'll be happy to get back, or if you want to do a virtual meeting, just tell me you need a virtual contact, and we'll find some time when you and I can get together at some convenient meeting. Let's talk a little bit about university policies real quickly, because it's part of the boilerplate. The university makes me do this, but it's still probably good to know. Incomplete grades. So if you can't finish it, you got 12 months to finish it out. If you don't finish out an incomplete after 12 months, then that incomplete changes to an F. And again, because I am a retired faculty member, you may or may not be able to complete it with me. And it's probably doubtful, unless they really guilt me in. I don't think I'll be coming back, but maybe I will. We'll see. Responsible conduct, that goes without saying. Don't cheat on tests. Don't cheat on your homeworks. I'm not here to be a policeman. Can you cheat on my test? Heck yeah, you can. If you really wanted to, go sit next to a smart girl, but who are you cheating at that point? We're all adults now. Don't take advantage. Just do your own work. And even if you get a B, I'd rather have an honest B than a dishonest A. All right. Again, disabilities, I've already talked about this before. So if you are a DSO student, I need you to register with DSO, because they're going to provide you with all the accommodations, whether you need if you're dyslexic, you need mirrors, they can provide you with the mirrors. If you are hearing impaired, they can provide you with hearing devices, closed captioning. Obviously, you see these lectures are all closed captioned. So hopefully for anyone who does have difficulty, they can see my words on the screen. These programs have gotten very good. I haven't seen too many mistakes so far. Non-discrimination statement, everybody is treated fair. I am the ultimate ref. I don't care what color you are. I don't care what religion you are. I don't care what sexuality you are, or if you're gay, bi, it does not matter at all. I will have none of that. And it will not be tolerated. Not by me, not by anybody at this university. And God forbid, if I ever hear anything like that, there'll be heck to pay for sure. So you treat everybody respectfully, and we will all get along very, very well. If you want to see the harassment policies, here they are. You can look at those directly. But this university can kick you out. You start doing any of that kind of nonsense, you're out of here. Lastly, supporting students in distress. Obviously, these have been challenging times. I don't think any of you want to be learning right now on your computer, and I'm sure you don't want to see my face on a screen right now. But that said, we all run into difficulties. And I will tell you from my own history that I have had very significant challenges, mental challenges in my life. I have to take medicine. I have to go to therapy. This all happened because of some tragic events in my life many years ago. But everybody has their demons, and we all need to support each other. For me, unfortunately, I waited way too long because of ego, the macho man syndrome. I thought I could do it. I couldn't do it. And eventually I had to go to a special hospital for a while. But I'm feeling much better. And so hopefully, if you are in that kind of a way, please, 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 please let somebody know. You don't have to tell me, you don't have to tell anybody else, but just if you're feeling bad, you got to let somebody know, because it was only when I started talking about it and was honest with myself, and my therapist told me that I should be completely honest, that I began to feel better. And hopefully that will be your story as well. All right, so that is the syllabus. Again, it's online, it's on the Moodle page, so you don't have to worry about that. So I'll stop that share for a moment. Now let us continue on, and let me bring up a share screen again, but this time I'm going to share something else. Let's go over here. Exams, the project. The project, I'm going to wait a little bit on the project. I'll talk about this project next week. Because this is drop add, we're going to wait on this a little bit, because I want to flush out, even in my own mind, what I would like to see you do with this project. I think hopefully you'll find it not a burden, but something that you will really embrace and hopefully find. I know a lot of you have to take this course, but I hope some of you appreciate chemistry after this is all done. All right, lastly, the expected prerequisites are Chem 101. So I'm going to talk about this right now. And right now, this is my iPad. So hopefully everybody can see this relatively clear. So I am going to start off with a general chemistry review, just a brief general chemistry review. And we're going to talk about atomic structure, bonding, ionic and covalent bonding, especially covalent bonding I'm going to talk about. And we'll talk about polar covalent bonds. And then lastly, we'll talk about acid-base chemistry. Two different kinds of acid-base chemistry, by the way. Acid-base chemistry as it applies to Bronsted acids and bases, hydrogen, H+, donated or being taken away. The donors are acids. The group that's taking it away is the acceptor, that's the base. And we'll talk also about, especially for organic chemistry, probably even more important than Bronsted is Lewis acid-base chemistry. And instead of talking about protons, Lewis acid-base chemistry focuses on electrons. So we'll talk about that in just a moment. All right, so let us go on now. I'm going to bring up get my pen here. And let's just go, oh, somebody else is joining us. So let's talk about atomic structure for a moment. So you remember, and since organic chemistry is the chemistry of carbon, that's one definition, the chemistry of carbon. We're going to talk about carbon for a moment just as a representative element. So here is, let me get a pen. Here's carbon. All right. Now we're going to talk specifically about a particular isotope, carbon-12. What does the 12 mean? Well, that's the atomic number. So basically that tells you, I'm sorry, carbon-6 is the atomic number. Carbon-12 is the mass number. So the 6 tells you how many protons are in the carbon nucleus. The 12 is the mass number, and that's the number of protons plus neutrons. All right? So if that's the protons, and that's the protons plus the neutrons, we know that the isotope carbon-12, people still joining us, the isotope carbon-12 has 6 neutrons in it. And that's the most popular, most populated isotope. Carbon-12 is the most popular. 99.9% of the carbon found in nature is carbon-12. We do have carbon-13, another isotope, always 6. So if you ever see carbon, the atomic number is always a 6. But in this case, this isotope has 7 neutrons. And you've probably seen carbon dating and those sorts of things. So a lot of times we're going to use carbon-13 as a tag, as a way to put an isotope into a molecule that we can follow. So we'll talk about that later. All right. So carbon again, carbon-12, has 6 protons, 6 neutrons, and in this case, 6 electrons. Do you see there's no charge on the carbon that I just drew? There's no C plus or C minus. So that's neutral carbon. Carbon without a charge has 6 electrons in it. So that electronic nature of the atom is going to be very important to us. So carbon then, do you remember back how we did the electronics in the atomic electronics in Chem 101? 1s2, 2s2, 2p2. Look at that. 2, 4, 6. There's 6 electrons, and those are the atomic orbitals. Those are the orbitals around the carbon atom. Now, another thing that I hope you remember, and if you didn't, this is going to be important, is in organic chemistry, the valence electrons are the most important. So how do we define the valence shell of any atom? It's the uppermost s orbital and any partially filled orbitals above it. So let's look at that carbon right there. The uppermost s orbital and any partially filled orbitals above it. So these are the valence electrons. So what are these down here? These are called core. It's not that the core electrons are unimportant. They are, but they're more involved in the shielding effects of the nucleus and other things. So, but we're going to focus more on the valence electrons of carbon. So if we were to draw the Lewis structure, hopefully you remember that as well from your Gen Chem. The Lewis dot structure. So here's carbon. The way we draw the Lewis dot structure is we take the number of valence electrons. In this case, there's 4 of them, right? There's 4 valence electrons. So we're going to put an electron here in the north hemisphere, an electron here to the east, and an electron here to the south, and an electron here to the west. So there are 4 valence electrons in that structure. Now, when it comes to bonding, we're going to see that these electrons are going to, when we talk about a covalent bond, it's a sharing. So I have an electron and you have an electron, and we're going to combine our electrons into a new orbital. We're going to take our atomic orbitals and we're going to put them together and we're going to make a molecular orbital. Now, let's just take hydrogen and the hydrogen atom. Hydrogen is element 1 in the periodic table. Carbon, again, is element 6, but only 4 valence electrons in carbon. Now, as you can see, I look at the carbon and I look at the hydrogen, and I can make one bond because hydrogen only has 1 electron to give. Now, how are we going to show this bond? Well, you're going to draw an arrow. Arrows in organic chemistry are very important. So we're going to take 1 electron and we're going to put a curly arrow, just like that. Looks like a single fishhook, doesn't it? When I'm moving 1 electron, look at the top of that arrow. It has a single fishhook. Now let's look at the hydrogen. 1 electron. I'm going to move those electrons here. And I just made a new bond by combining the 1s orbital on hydrogen and the orbital in that electron there. Now, this is not, we'll talk about these electrons here, not in this, not right now, but later on. These 4 electrons are known as electrons that are in hybrid orbitals. But hybridization of carbon is something that's more involved in greater understanding of organic chemistry. I'll briefly introduce it to you, but we're not going to go into great detail about hybridized electrons. So right now, let's just keep it simple. We're going to make a covalent bond, a simple 1 covalent bond between a carbon and a hydrogen. So we just did it. So you see there? So let me get a different color here. So that single bond there represents 2 electrons. Anytime I draw a single line, that represents 2 electrons. Now you can see we could do this 3 more times, right? If I have 3 more hydrogen atoms, I can keep doing this. So let me go back to black ink. And do it 3 more times. So then I have carbon, hydrogen, 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 hydrogen. You just drew the first, let's see if I can move this up a little bit, or hopefully everybody can see that. You just drew your first organic molecule. That molecule is known, oh, some more people still adding, that's okay. That molecule is known as methane. Oh, sorry, misspelled. Methane. CH4. Notice I just drew this a couple of different ways. I drew it like this, and I drew it like this. Those are 2 different representations for methane. All right. Now, let me get another piece of paper here. Let's see if I can add. There we go. All right. So let's look at how we can represent organic molecules real quick. So I just showed you the simplest way. That just shows you the ratio of how many carbon atoms to how many hydrogen atoms are contained in the methane molecule. There are 4 hydrogens for every carbon. Now, then I also drew it like this, with the hydrogens written out. That's yet another way to represent methane. Now here, this gets to a point, hopefully you remember it. If you didn't, you're going to have to review that general organic and biological chemistry. If you notice here, the way I've written this, you see how these all look like they're 90 degrees? That's not right. The angles between all of those bonds is not 90. And that's due to a topic known as valence shell electron pair repulsion, VESPER. What VESPER means is that like charges that are the same, want to get as far away from each other as possible. They want to get away from each other. Now, a central carbon atom and 4 different electron pairs, if they want to get as far away from each other as possible, this is what it looks like. Oh boy. What is that? What does that wedge and what does that hash mean? Well, they're just single bonds. They are just simply single bonds. So there's no difference between what I drew here and what I drew here. Here's this bond, here's this bond. Here's this CH, here's this CH. All I'm showing you is spatially on a 2-dimensional surface, a 3-dimensional object. You know, that's the bad thing about chemistry is molecules exist in a 3-dimensional environment. So putting them on a flat piece of paper requires some creativity. So we use the hashes and the wedges to represent things. The hashed line means that that bond is going behind the piece of paper. It's not in the plane of the board. It's not in the plane of that piece of paper. It's behind the paper. Do you see this wedged line right here? When you wedge something, you're telling the reader that that single bond is coming off of the paper. It's coming out at me. If you draw a straight line, these are in the plane of the paper. So if you were to do these angles, you would find that all of these angles now are 109 degrees. That's a terrible line. 109 degrees. That's a tetrahedron. And that's what carbon is. When carbon, that's one of the kinds of carbon, by the way. We're going to talk about 3 different types in this class. Let's just stick to the most simple, saturated carbons and hydrogens. So ones that have no double bonds, no triple bonds. You talk about a carbon atom that has only single bonds to it. That carbon atom must be tetrahedral. All the angles 109. So you see, we're going to talk about shape a lot. But that's not the only thing we're going to talk about in this course. Because molecules, the way they interact with other molecules, it's not just the shape, but it's also the electronic nature of the molecule. And to do that, we're going to need a concept known as electronegativity to determine the charges within molecules. You know, if all the atoms had the same electronegativity, there would be no charge. So something like hydrogen, molecular hydrogen. There's H2. There's no difference in the electronegativity in that molecule, so there's no polarity. Now, in methane, there is a slight difference between the electronegativity of a carbon atom and that of a hydrogen. Now, what is this electronegativity thing? I don't remember that. Do you? Remember from 101? Electronegativity? Electronegativity is the ability of an atom to pull electrons towards itself. Fluorine is the most electronegative. That's a 4. There's nothing more electronegative than a fluorine atom. Fluorine always takes electrons from other atoms. Fluorine never gives up electrons to other atoms. So carbon has an electronegative, or let's do it this way. Let's use the actual symbol. What is the symbol for electronegativity? So the symbol for electronegativity, it looks like an X, but it's actually what we call chi. So for the chi for carbon is equal to 2.5, okay? The electronegativity of a hydrogen is approximately 2.1. So the absolute electronegativity doesn't really help us much in terms of looking at a molecule and the charge distributions. It's really the delta chi for the carbon hydrogen bond, 0.4. That's the delta chi. Get rid of this hydrogen real quick. Now, that's not terribly big. A difference of 0.4 is relatively modest. However, it does tell us that the carbon atom, let's get black here. The carbon atom is slightly negative and the hydrogens are slightly positive. This symbol that I just drew, delta minus and delta plus, that just means partial, slightly. So the hydrogens are slightly positive in nature, and the carbon is slightly negative in character in the methane molecule. But it's very small. So methane is a gas at room temperature. And we're going to have a whole lot more to say about this next lecture when we start talking about the hydrocarbons. For now, we're just really talking about electronic structure and how electronic structure leads to shape, how the electronic nature can lead to charge distribution. And now once you know the shape and the electronics within a molecule, then we can predict how that molecule will interact with other molecules or with itself. Does methane stick together? Not very well. So that's why it's a gas. Let me show you another. I'm gonna have to add another piece of paper here. Let me show you another molecule, very similar. This is water. All right. So let me draw the Lewis structure for you for water. So oxygen is element 8. So there's 1, 2, 3, 4. Remember? And we need 2 more because the valence shell, oxygen is element 8. But remember, those inner 2 electrons are core electrons. We're only drawing the valence shell, the outermost shell of electrons. So we need 2 more here and 2 more here. Do you see how I paired those up? So I drew 4 electrons around, and then I start pairing them up. That's how you draw Lewis structures. All right. Now, once they're paired up, they're not available to bond. Not in a conventional sense. They could form covalent coordinates, but that's later. That's for a later lecture. So the 2 places that we can form chemical bonds are here and here. So let's just put our hydrogens in there. So we've got an oxygen atom. Lone pair, lone pair. By the way, that's what we call these. Lone pairs. Forgot to mention that. Lone pairs. Now, we just drew, let's go ahead and draw our bonds to hydrogen now. Oh, didn't need to do that, need a little thicker. And there's the structure for water, H2O. I don't know why that's not showing. Oh, there it is. A little slight delay there. Now, again, all these angles should be 109, but they're actually a little bit more compressed. So this angle here should be 109. Remember, it's 4 electron pairs around an atom. That should be tetrahedral. But in this case, it's actually kind of compressed because these lone pairs, the lone pairs kind of push down a little bit harder than bonding pairs. So that's why that HOH angle is slightly compressed from 109, okay? Now, so here's water, but chi for oxygen is approximately 3.5. Electronegativity of oxygen is 3.5. The electronegativity for a hydrogen atom is again approximately 2.1. So let's do the delta chi. The delta chi for the oxygen-hydrogen bond is equal to, oh, I'm sorry, this should be 2.1. Messed that up, 2.1. Is 1.4. Huge, huge delta chi. That means the charges are massive in this molecule. So whereas in methane, we had a tiny little delta plus, delta minus, not here. The oxygen is hugely electronegative. The hydrogens are massively positive. So that led to a big, big difference in charge here. Now, just because you have dipoles, that's what this is called, a dipole. Remember the 2 poles, dipole. Plus and a minus. There's a dipole going in that direction. Let me make a different color here. So remember what that kind of a line is? That's called a vector. A vector. The tail of the arrow is the plus side, and the point of the arrow always goes to negative. So we've got 2 bond vectors here. We have an angle between these 2. Right through the top, right through there, both of those. So if we look at it, this side is very delta positive of the water molecule, and way up here by the oxygen is very delta negative. Okay, so this is now a molecular dipole. This is an important point. Just because you have bond dipoles doesn't mean the overall molecule has a dipole moment. I'll show you that in just a second. The overall molecule in water does have a huge bond dipole because this angle here is 105. Now let me get another piece of paper and we'll finish this up with this last piece of knowledge. So let me go and get one more piece of note paper here. Now, I'm going to draw for you carbon dioxide, CO2. Don't worry about how I got this structure. But let me just show you something about bond vectors and molecular vectors. So here's the Lewis structure for carbon dioxide. Okay. Carbon dioxide is linear. this angle, the carbon, oxygen, oxygen is 180 degrees. Electronegativities. Let's look at the electronegativities. Chi carbon again, approximately 2.5. Chi oxygen, approximately 3.5. Delta chi for carbon oxygen, 1.0. Big. 1.0 is a big one. Now, so I have two big bond dipoles. Here's one. Remember, you always go from the positive to the negative. Your arrows go from the positive to the negative. So here's one vector. And here's the other vector. But remember what vectors are. Vectors have magnitude and direction, right? Magnitude and direction. So I've got a huge bond vector pulling in one direction, but I have an equal and opposite vector pulling in the opposite direction. So the molecular dipole here is equal to 0. The two bond dipoles canceled out. So there's no overall bond dipole in carbon dioxide, molecular dipole. So carbon dioxide is not a polar molecule, whereas water is a very polar molecule. Okay? So water can form hydrogen bonds, very sticky. When I say hydrogen bonds, that's like the ultimate electronic stickiness between the particles. So carbon dioxide doesn't like to be polar in polar stuff. So if you crack open the fizzy water, don't you know that the soda or the fizzy water gets flat? That's because the carbon dioxide doesn't want to be in the water. It's going to evaporate, get out of the water. So, because remember, like dissolves like. Polar things like to be in polar things. Non-polar things like to be in non-polar things. So carbon dioxide may have a good solubility in a non-polar solvent, but water has a good solubility in polar solvents. And we're going to see that throughout the class. All right. So we're going to wrap it up here because it's about time. I know you have other classes to go to. So hopefully, let me stop my share here. This will be posted. I'll send everybody the link to it. Hopefully everybody was able to get a little something out of that first lecture. And again, don't worry if you didn't get it all. You can review it 100 times if you want. Pause it, fast forward it, go back. I don't care. As many times as you wish. So I wish you safety. I wish you good health. I wish you, please wear your mask, get vaxxed, get boosted if you can. You know, we're kind of all in this together. So we got to help each other out. So adios for today. We're going to do another Zoom on Thursday, all right? So come Thursday, I'll send you the link, Wednesday night or Thursday morning. But please, hopefully you can show up, for the class. But again, if you miss it, don't worry about it. You'll be able to see it later. All right? Adios.
Dr. Brown, I have a question.
Sure.
Where's
Yep.
our homework going to be posted?
In the Moodle page. But no homework this week, though. So the homeworks are all going to be Moodle homeworks. Okay.
Okay.
So you'll kind of do those homeworks online. Have you ever taken a Moodle quiz or a Moodle assignment?
Yes.
Okay, good. So I guess a lot of you are used to little Moodle quizzes. It's just like that, but it's Moodle homework. And so
and then
that's where you'll find that, but not this week.
We don't have to buy anything for this class, correct?
Nothing. Do not buy a thing. So you'll do all your modeling through the computer. The books are all, I've already shown you the books. They're on the Moodle page. So do not purchase a thing.
Okay, thank you.
You're welcome. Any other questions?
I have one more question.
Sure.
I was wondering for the modeling programs, if one lecture you would be able to go over like how to use those.
Oh yeah, absolutely. Absolutely.
Okay, great.
Yeah,
Thank you so
and
much.
we'll do that. Maybe I'll try to do that next lecture, but definitely, certainly in class on next Tuesday, because that's where we'll start making molecules and then putting them into 3 dimensions where you can rotate them. You can dock them into active sites. Maybe we'll pull up some big proteins and I'll let you spin around DNA or proteins. It's pretty cool. It's very powerful. Any other questions? All right. Well, adios. Have a great day. I'll see you on Thursday.